audible?
Voice is audible, sir.
Hello.
You're audible, sir. You're audible, sir.
Good evening to all. Myself, Dr. K. Basant Kumar, working as an assistant professor in the Department of Physics, Vardhaman College of Engineering. It is my pleasure to introduce today's research person, Dr. Asadi Srinivasulu, sir. Dr. Asadi Srinivasulu is a distinguished academician and researcher with over 24 years of experience in data science, artificial intelligence, cloud computing, and software engineering. He holds a BTech from SV University, pursued his MTech in Intelligence System at IIIT Allahabad, and he completed his PhD in data science from JNTU Anantapur, and is currently pursuing a second PhD in artificial intelligence at IIIT Allahabad. He is also serving as a visiting researcher at CRCK, University of Newcastle, Australia. He has held key roles including head of researcher, head of researcher research and open labs at Blue Crest University. Subject matter expert at Delight. It was located in Delhi, and head of IT department at SV College of Engineering. Dr. Asadi Srinivasulu sir has evaluated 50 PhD theses, guided numerous scholars, and holds 30 plus global certifications. He is having more than 200 research publications, including 44 SCI and 57 Scopus Web of Science papers, 9 textbooks, 36 book chapters, and 4 patents. His research is widely indexed by Springer, IEEE, Elsewhere, and Scopus. He has delivered 150 plus invited talks, participated in 200 plus workshops, and secured major grants, including DST self funding. Is a member of professional bodies like IEEE, ACM, ISTE, and IAENG. He serves on editorial boards and reviews for the top journals. So his achievements include the Bharat Vidya Ratna Award, the Best IT Teacher, ITAP 2020, a Lifetime Achievement Excellent Award in 2022, then Best Academic and Research Guide Award in 2025. So with this, I would like to welcome you, sir, Dr. Asadi Srinivasulu, sir. We are waiting for your lecture. So over to you, sir.
Yeah, thank you, sir, for a nice introduction. So last 5 days, you might have seen the complete concepts of quantum computing, qubits, superposition, entanglement, interference. These are the four major concepts every speaker might have spoke about the concepts of quantum computing. Now I will take another direction by using these all quantum computing major areas, how this quantum computing is going to play a vital role in order to solve complex applications such as drug discovery and healthcare department and traffic data analytics and space applications, whatnot. There are plenty of applications we can solve very easily without any burden, like unless classical computing we are using a 0 or 1. Here exponential computing power we can generate with help of this quantum computing in order to solve cybersecurity issues, challenges of malware detection or any cyber instance, cryptography, so many complex applications in big data applications. And you can see deep learning, machine learning. We are using as a techniques to solve complex applications, especially in healthcare system and space applications, wherever data is presented. If you want to search very quickly by using by using Grover's algorithm and source algorithm we are using for encryption, such a complex applications we can solve with the help of artificial intelligence, machine learning, and deep learning techniques. Why I have taken this AI, ML, and DL? It is a hybrid models combination we are using, like the intelligent behavior in a machine to solve complex applications. We are using AI. In this AI umbrella, we have machine and deep learning techniques. Machine learning is a part in artificial intelligence, learning from the observational data with the help of supervised learning, unsupervised learning, and reinforcement learning. We are using and solving complex applications. And the extension of machine learning, we are using deep learning concepts. Then what is the difference between here machine and deep learning? Learning from the observational data with a deep manner by increasing number of input layers, number of hidden layers, number of fine-tuning parameters, and activation functions, and dropout. We are solving complex applications with help of quantum computing. This is my justification of the title today. And if you are having any doubt for in my explanation, please post a question in the chat box so that I can explain each query uh, at the end of the session. Please feel free, no hesitation. You can post your query, and Professor Dadamia sir will read out each question, and I'll answer for each question. Okay. So once again, a warm welcome to 1 week online professional development program. And this is the last day. And I'm going to demonstrate practical applications, how traditional systems are unable to perform complex database applications, and to overcome those, we are using quantum computing, still emerging, and with exponential computing power, you can see in near future with the solving of cyber security issues and the computer networks issues, healthcare issues, drug discovery applications, and so many complex applications we are going to solve with help of quantum computing. Recently, from Delhi to Dubai, we are not using near future flights. So we are using undergoing trains. By using this quantum computing power, they have utilized this quantum computing algorithms with the help of AI, machine deep learning techniques. They have developed a sophisticated train route from Delhi to Dubai. The quantum computing playing vital role here. So this is my background. Already Professor Dadamia explained. I have now second PhD this December. I'm submitting my thesis in the specialization of artificial intelligence. I'm doing numerous publications, especially Science Citation Index. Today you might have seen my LinkedIn. This year I have published 6 papers in SCI Q1 journals in Scientific Reports Springer Nature only. Remaining journals also are there, like Plus One and IEEE and Springer Nature, and a few more SCI journals, Frontiers, etc. If anybody interested, we can collaborate and we can do collaborative research work. Irrespective of the domain, I can work. And these are my research interests. Right now, I'm giving a training for US PhD and employees in generative AI applications using machine and deep learning techniques. And these are my research interests: data science, cybersecurity, health data analytics. Right now, I'm doing last 2 years Australian groundwater and soil. We are finding the PFAS contaminants in the groundwater. Real-time data we are utilizing under the very good project, ARC project. and Australian funding projects. They have provided so many millions of amounts for these projects. And right now I'm doing, yesterday also, I have acted as a session chair and I have presented paper on microplastics, how we can detect microplastics and classify and finding the contaminants in that microplastics by using machine and deep learning techniques. So these are my publications. You can find in IEEE Explore and Scopus, Web of Science, and I have a YouTube channel. You can search my name, Dr. Asadi Srinivasulu. You will get nearly 500 videos on different technologies. So I'm a corporate trainer on data science applications using AI, ML, and DL techniques. I'm a corporate trainer on generative AI applications using ML and DL techniques. And this is the syllabus of generative AI. That is a latest subject in the field of artificial intelligence extension. You may learn transfer learning, explainable AI, federated learning, generative AI. So many latest technologies are emerging and coming. You need to adapt all those latest IT technologies. So these are the 13 core subjects. In order to solve all these subject complex applications, we are using quantum computing. Keep in mind why I am explaining these applications. We need computing power. We need high computing power. Instead of classical computing, we are using zeros and one. But here we are using qubits, superposition, entanglement, interference concepts. We are integrating and leveraging with the AI, machine, and deep learning techniques to solve such a complex applications very easily. So 4 case studies like groundwater and climate change data analysis by using AI, ML, and DL techniques, and COVID-19 like health data analytics, virus prediction and detection using AI, ML, and DL techniques, Ebola virus, and uh, um, chronic diseases like prostate, breast, skin, lung cancer predictions by using various AI advanced techniques. And I'm a corporate trainer on cybersecurity. In order to solve applications of cybersecurity, we are using quantum computing. Now I'm integrating leveraging of artificial intelligence and machine and deep learning techniques to solve complex applications. So this is the syllabus of cybersecurity. By using 13 concepts, we are solving cryptographic applications, very complex, unbreakable applications we are solving with help of quantum computing. Keep in mind. And I'm a data science trainer. Last 5 years, I'm training in this subject. And now everybody is looking for generative AI and advanced concepts like quantum computing. And within 60 seconds, what is happening? How many users are connected right now? I would like to see. Okay. So in this case, why, sir? Why should I count a number of users within 60 seconds? Means they are generating huge volume of data. If you see the social networks like Facebook, Twitter, and so many social network sites generating huge volume of data, where we are getting this huge volume of data, there is a background called cloud computing nowadays. Okay, in this in this uh, we are living in this terabytes and zettabytes of era. How this huge volume of data we are getting as a source. So we have a background called cloud computing. Cloud computing is a pay and use technology. Without internet, you cannot perform such kind of computing applications. So cloud computing is a internet based technology. So cloud computing is a collection of, see, in this cloud computing, there are major two concepts like data center and virtualization. Why should I explain data center? Because we are correlating with our quantum computing concept, like collection of high integrated servers, computing servers at one place is called a data center. Each MNC having their own data center at beside of a Shor, because it is generating a high computing heat. I mean, it generates too much heat to generate. That's why they are keeping the data center beside at seashore. So we are getting the computation power from that cloud computing. Soon it is going to replace with the quantum computing processing. So next concept is virtualization. Virtualization means it is the ability to perform multiple tasks in a single system with help of virtualization technologies like a hypervisor, Zen, Virtual Iron, etc., VMware, etc. So with these two concepts, I'm concluding cloud computing concept here. We are generating a huge volume of data from various sources, maybe weather forecasting, we are generating banking system, we are generating huge volume of data. Wherever data is there, for searching purpose, searching of the database, we are using Grover's algorithm. My dear friends, you might have seen source algorithm and Grover's algorithm. These are the quantum computing algorithms, very popular right now. So you must learn those algorithms. You must inculcate how to utilize source algorithm and Grover's algorithm for our applications. Okay, see, can you imagine 6,94,000 video hours viewed within 60 seconds? 2.4 million Google searches happened. So 10.4 million viewing minutes happening in Instagram. 11,035 fake accounts removed within 60 seconds. Can you imagine? So if you click this URL, you come to know number of users right now connected in this internet world. What is internet? Network of networks. What is network? Interconnection between the computers in the fashion of local area network, wide area network, metropolitan area network, etc. See, can you read? Can anybody read this number? See, you can't. Such a huge number. So these are the statistics we can generate. See, with the population, how many people are using this internet with the mobile gadgets and generating huge volume of data. So that's why emerging algorithms like we are using Shor's algorithm, Grover's algorithm to solve complex applications, especially in cryptography, in cybersecurity applications, drug discovery applications, big data applications, data science applications, whatnot. Wherever complex data is there, we are solving with the help of quantum computing. See, this is the growth rate of so next, see, same internet live statistics. If you use this URL, and we can see the internet users in the world, total number of websites opened, emails sent today within 60 seconds, Google searches, blog post, whatnot. So here there are problems. Wherever data is there, there is a problem like cyber security issues. To solve cyber security issues, we are using quantum computing algorithms like Shor's and Grover's algorithm. Keep in mind, same thing I have incorporated in the slide, and you can see the number of users are increasing. Automatically, the size of the data center also increases. So in traditional systems, if I'm pressing capital A in my keyboard, can my computer can understand capital A? No. Internally, it converts into ASCII value. What is ASCII? American Standard Code for Information Interchange. For every key in 108 keys of the keyboard, for every key there is a ASCII value. Capital A value is 65. If you divide it by 2, we are getting the binary equivalent number is 100001. So internally it calculates, and within fraction of seconds we are getting the output of capital A. You have pressed capital A. That means computer understands only binary language. 1 bit is 0 or 1, 4 bits is 1 nibble, 8 bits is 1 byte, 4 bytes is 1 word, 4 words is 1024 bytes, 1024 bytes is 1 kilobyte, after that megabytes, gigabytes, terabytes, petabytes, hexabytes, octabytes. Hi, I'm Robo. My speed is 1 terabytes, my memory is 1 zettabyte. 1024 octabyte is 1 zettabyte. 1024 zettabyte is 1 yottabyte. 1024 yottabyte is, see, again I searched in the internet, is there any measurement terminology of measuring the data in computers, servers and data center? Yes, there are two more terminologies presented. That is 1024 yottabyte is 1 brontobyte. 1024 brontobyte is 1 geobyte. If you ask me after that, 1024 geobyte is infinity. So why I am explaining? You must clear in this slide, because this is happening with help of classical computing like 0 or 1. That's all. Now we will see the excellent concept of quantum computing, how we can measure the data in computers and servers and data centers. Same thing we can represent in mathematical terminology, normal range and big data range. So kilobyte is 10 power 3, megabyte is 10 power 6, gigabyte is 10 power 9, terabyte is 10 power 12. In big data range like petabyte is 10 power 15, hexabyte is 10 power 18, zettabyte is 10 power 21, yottabyte is 10 power 24, brontobyte is 10 power 27, geobyte is 10 power 30. This is the way we are measuring the data in computers, servers and data center. Keep in mind. Now we are moving to quantum computing measurement, units and description. 1 qubit, you might have known, everybody knows measure better than me, because last 5 days you got plenty of knowledge. You got so much knowledge on this quantum computing. Recently, I have started learning many articles on this quantum computing. So I'm thinking you are better having knowledge on this quantum computing, but I'll try my level best to meet your requirements today. 1 qubit is it is a basic unit of quantum information, and we are using superposition state, either 0 or 1, 0 angle or 1 angle at a time. Okay, so by using within the parenthesis we are solving, and entangled pair, 2 qubits linked with correlated states, quantum register, collection of multiple qubits, 1 quantum gate, basic quantum operations we are using Hadamard gate, XYZ gate, C0 and T gate, etc. Gate depth, we are using number of sequential gates in a circuit, quantum circuit, series of quantum gates for computation purpose, circuit fidelity, like percentage of accuracy of quantum circuit execution, gate fidelity, accuracy of individual quantum gates, one shot, one measurement attempt of a quantum circuit, measurement error rate, probability of incorrect measurement. This is the unit and description. See the coherence time, that is T1. So qubit energy relaxation time, and coherence time T2, qubit phase relaxation time. So decoherence rate, rate at which qubits lose quantum state, quantum volume, that is QV, a holistic metric for system performance, and logical qubit, we are using error corrected qubit made from many physical qubits. So physical to logical ratio, we are using unit. Qubits needed per logical qubit, example 1000 ratio to 1. So error threshold and maximum allowed error for fault tolerance of we are using QC. Then cryogenic temperature, that is similar, I mean, more or less 15 millikelvin for superconducting qubits, and photon wavelength 1550 nm for photonic qubits. So ion trap frequency, MHz range for trapped ions, quantum energy unit measured in joules or electronic volts. So quantum speed up, ratio of quantum versus classical performance, and QEC syndrome rate, error detection frequency in quantum error correction. And see, those things you might have studied last 5 days. Now I am correlating with what classical computing uses measurement to the computing, quantum computing scaling units. Now I'm comparing with the ranges. How do we can measure the huge volume of computing data with help of quantum computing scaling units? These are the extended ranges, like similar to kilobytes, megabytes, gigabytes format. We have a 1 qubit, QB, that is single quantum bit, and 10 qubits small scale test devices, 50 to 100 qubits, that is NISQ processors, and 1000 qubits early fault tolerant error, and 1 million qubits. Can you imagine? See here, exponential data we are scalable means the size of the data is unmeasurable, and you can't imagine such exponential computing power we are generating soon. Scalable universal quantum computer, and the quantum volume like 128, 1024, 4096. It gives 10 power 6 exponential increased computational complexity capability. And gate error, see 10 power minus 2, 10 power minus 3, 10 power minus 4, 10 power minus and so on. It progress towards fault tolerance. If any server or data center not working, even though remaining systems will take and initiation to provide the processing and computing power without any delay. Such type of concept is called fault tolerance. Coherence time, see here, we are improved stability. This is the way we are measuring a quantum computing scaling units. Keep in mind. And this is the data science training. I don't want to spend on this time on these topics. Why Python program? See, why I'm this data science syllabus? Because in this data science complex applications with the help of AI, machine and deep learning algorithms, we are integrating same concepts we are leveraging to quantum computing. That's why I'm to solve such complex applications in programmatic, we are using Python programming. Python is so popular because of rich number of libraries are presented. Better you can use irrespective of the computer science faculty. You can use Python if whoever interested for your area. I will give you number of libraries so that we can solve your research problems very easily. Then statistics is required to solve. See, for even quantum computing, we require mathematics with inclusion of statistics and any one programming language. And to solve complex applications, if you want to write a program efficiently, you need to have data structures and algorithms. If you want to store a huge volume of data in a system, server and data center, we require a database management system to store complex data. To solve such kind of complex problems, we need to have artificial intelligence, intelligent behavior in a machine, just like a humanoid robots like Sophia. Recently, Saudi Arabia, Sophia took the citizenship of Saudi Arabia. She can cook, she can do many things. She can sweep, she can play, many things. How a human being is performed, same thing Sophia can perform. Like there are plenty of humanoid robots like Asimo, Sophia, so many are presented. So these are the concepts we are studying. The advanced concept solve complex applications, we are using generative AI applications. The popular algorithms like generative adversarial networks. See, recently one Japan professor released the application app. It came as an app right now. Earlier, 5 years back, he generated application like facial expressions, how over the period we are changing from 1 year baby, 5 year baby, 10-year baby, I mean 15 years, 20, 25 years, 30, up to 60 years. How our face expressions, face changes over the period. Such kind of applications done with help of generative adversarial networks and variational autoencoders. Very popular techniques. And defaking applications, you might have heard. Defaking means which image is original and duplicate. Recently Rashmika Mandana, her photo they created as a defaking image with the help of these techniques. GAN, variational autoencoders, autoregressive models, and neural autoregressive density estimators, self-attention mechanisms, deep generative models, etc. So, in order to solve any data-related applications, we are using data mining with the help of classification, clustering, association rule mining techniques. Then we are dealing with the natural language processing like English, Hindi, Chinese, Spanish. How easily we are communicating each other. That is a complex application. Now, in order to solve such complex application, we are leveraging with the quantum computing algorithms right now. We are moving now quantum computing algorithms. We are replacing traditional algorithms to solve natural language processing. Means study of different languages, study of linguistics, such type of complex applications with the help of quantum computing algorithms we are solving. These are the traditional techniques of natural language processing, and we are replacing soon with the quantum computing algorithms. So wherever data is there, big data applications, complex applications, we are introducing quantum computing algorithms. So in order to solve complex applications, we are using machine and deep learning algorithm. The basic concept for machine and deep learning algorithm is a ANN. We are creating artificial neurons, collection of artificial neural networks, and we are solving complex applications, health related applications, and traffic data analytics, weather forecasting, NASA data applications, space applications, etc. Keep in mind. So I have already explained machine learning. There are learning from the observational data with complex data sets wherever is presented with the help of supervised learning. Algorithms are plenty like support vector machine, Bayesian networks, random forest, so many techniques, neural networks, etc. And unsupervised learning is nothing but I don't know the size of the data, but I don't know the target class, but I would like to apply a similarity measure to find the clusters. Clustering is a collection of objects, that objects having similar behavior in the nature. So with the help of C-means clustering, fuzzy C-means clustering, agglomerative clustering, density-based clustering, etc. So and then to solve gaming applications. Now quantum computing entered into gaming applications to solve very complex gamings by using reinforcement learning algorithm. Reinforcement is nothing but based on the punishment and reward we are solving the problems. With help of reinforcement learning algorithms are plenty. Then deep learning. So the middle size of the data means whatever the complex applications unable to solve with the help of machine learning, those applications we can easily solve with help of deep learning algorithms like convolutional neural networks, recurrent neural networks, like explainable AI, federated learning, and generative AI, many application, many techniques we are incorporating to solve complex applications. Now we are replacing with the quantum computing algorithms. Keep in mind. So AR, VR technology is so popular. Augmented reality and virtual reality nowadays, it is also emerging technique. Here also complex applications for solving, we are using quantum computing algorithms. So these are the recent projects we have completed under my artificial intelligence research laboratory and data science research laboratory. We have completed nearly 153 projects, and with help of Master of Technology students, MS students, and PhD students. Okay. So now very interesting application with help of quantum computing, we have solved that application with for the small data set only. So very interesting question with practical demonstration. Please concentrate on this quantum computing with the inclusion of, with the leveraging of artificial intelligence and machine and deep learning techniques. I have solved one application, very interesting application. If I'm asking the question, when is your date of birth? Immediately saying, sir, my date of birth is 15/7/1978. Okay. So when is your death date? If I'm asking the question, you are getting angry. Sir, why sir you are asking when is my death date? Yes. Now we are living in this era. Now quantum computing era came into the picture. We are finding the solution approximate, not exact date, approximate how many years you can live in this earth. That problem we are solving, and so many researchers are started and a few models came. The solution for this death date, life to vector is a model. This is a AI model which solves the complex question and complex problem in in our human life. How many years I can live in this earth based on your activities, based on the input. We have incorporated machine learning, deep learning techniques with the inclusion of artificial intelligence, top 10 models to solve a death date. We are finding the human lifespan. Okay, by using life to vector model, it takes input like biological data, age, name, and weight, body mass index, cholesterol, many parameters. If you are increasing number of constraints, means number of parameters, so that we can expect very good accuracy of human lifespan we are finding. And output we are expecting the number of years Dr. Asadi can live, 65 to 70 years. Now that approximation, not exact death date, still it takes time based on your habitual activities, exercises, date of birth, height, weight, lifestyle factor, genes, etc. So many things we are considering to solve such a complex application. uh, and we are using machine and deep learning techniques we are finding. See, now I'm going to demonstrate. Write a Python program to find the death date or lifespan of a human being by using machine and deep learning techniques, by feeding the biological data as input, lifestyle habits and genetic traits using a rule-based scoring method and displaying the results with a computer bars. You can see that. Now I'm going to execute this program. You can see here command prompt. You can go. Please acknowledge me. My screen is visible.
Yes, sir, it is visible.
Yeah, thank you, sir. See, Python, I have used Python programming by leveraging of AI algorithms, machine and deep learning algorithms. I have integrated, and soon we are incorporating quantum computing algorithms. Not yet used, we are planning to use. So Python can be executed in two ways. One is interactive mode. This is scripting way. So I have written the program in Notepad. See, so this is the first program. You can see, write a Python program. See here, 1 second. So write a Python program to simulate and visualize same lifespan prediction of a human being, analyzing with the biological data, lifestyle factors, etc. I have incorporated with NumPy, numerical Python, and I have used Matplotlib for visualization. Bar chart I have generated with the help of this library. Define a function to predict the lifespan based on input factors. Adjust the score based on biological data. So many inputs, male, gender, diet, body mass index, so many parameters I'm increasing. Blood pressure, cholesterol. If you increase number of habitual activities, so that you will get drinking, diet, smoking, so many things. I'm predicting the lifespan. Now see, I have given my own data and my life to vector model is predicting. Python space. This is the very simple execution in your Windows system by using Python programming. See now my screen is visible, sir. There is a bar chart I have generated. So I have given my lifestyle factors. It predicted 77 years. Sir, my screen is visible, sir.
Yes, sir. Yes, sir. Yes, sir. It's visible.
Yeah, thank you, sir.
You're almost
Yes.
77 years you live in the world.
Yeah, I know. Based on my input parameters, it is predicted. Let's see. So still the research is ongoing, not yet stopped. Still it is ongoing. Such a tremendous applications we are solving with the help of this AI mission and deep learning. Soon we are going to use quantum computing so that we can uh, we can see the more accuracy again. For computing, it takes so long, we can complete within a fraction of seconds. So same application I have used for another person with the increase of biological data, input data. I have increased like date of birth, see 1990, height 175, weight 70, same program. See, it can generate very interesting the lifespan factor. 1 second. So notepad space, lifespan. See here. So this is the date of birth I have taken, same program, but I have changed the input parameters and these are the input parameters I have used, and I'm executing Python space lifespan. See, that depends on the, see, now it is predicted 73 years for that person. Okay, so likewise, actual lifespan and predicted lifespan. Now, these sort of complex applications, we are using quantum computing soon. The quantum computing playing vital role for computing purpose, especially. So you can't imagine such a huge computing power. Traditional systems unable to solve such kind of complex application. It is replaced by the quantum computing. Okay, so this is very interesting application. With this one, small introduction is over. Now I am moving to our core concepts and execution of 5 more case studies of quantum computing applications. So this is my channel. How many members are there in the group, Dada? Dada Mia, sir?
Sir, there are around 200 faculty and 350 students are there, but you have shared your channel also. Some of them might have joined through the channel
Yeah,
and they are
please, my dear
watching.
friends, you subscribe my channel. It is not for money, for my research purpose. Anyone interested, you can see the nearly 500 videos are available on different technologies, and you can share to your students. Please, it takes 30 seconds for subscription of my channel. Okay, and please encourage to see my all 500, nearly 500 videos. So, my dear friends, these are the concepts I would like to cover with the small introduction only because of time. So, introduction to quantum computing and qubits, you know very well. quantum circuits and gate models, and quantum cryptography and post-quantum security protocols I am going to explain now. Quantum machine learning, QML fundamentals I am going to explain now. And quantum enhanced threat detection and anomaly prediction, that application I am going to demonstrate. So some hands-on programming with QSKIT and IBM Quantum Lab for cyber use cases, and quantum AI algorithms for secure key distribution and encryption algorithms, how easily we can solve such kind of applications, and AI-driven quantum network intrusion detection system, and the quantum deep learning models, how we can use for classifying the malware data. And threats, cyber security threats, malware is one kind of threat. Cyber incidents, cyber criminal activities, malware detection, spyware detection, classification, and some hybrid classical quantum architecture for cyber security, and future trends like quantum AI for cyber defense in cloud and edge environments, etc. So our title justifies integration of quantum computing principles like qubits, superposition, entanglement, and interference with advanced artificial intelligence like generative AI, federated learning, explainable AI. Okay. And transfer learning we are using, incorporating, and we are leveraging with machine learning models like classification models, clustering models, association rule mining models, outlier detection models, recommender engine models, whatnot. And we are integrating with the deep learning techniques like CNN, RNN, and TensorFlow, Keras, PyTorch, and sklearn, Pillow, Matplotlib. So many frameworks we are integrating to build ultra secure and high performance cyber defense systems in this quantum computing for cyber security. Keep in mind, quantum computing is a paradigm for next generation. So in this paradigm, leverages means integrates with the qubits, superposition and entanglement and interference to achieve computational speeds for beyond classical systems, unless see we are using 0 or 1. But here we are enabling quantum resistant encryption algorithms, intelligent threat detection, quantum enhanced anomaly prediction, complex applications in computer science, in real-time environment, and secure key distribution we are leveraging with quantum computing algorithms. By combining all these quantum computing algorithms with AI-driven analytics, we can call it as a artificial intelligence hybrid models we are developing to solve complex applications. This approach provides unprecedented protection against emerging cybersecurity threats, criminal activities, including post-quantum attacks, making it a transformative framework for future cybersecurity in a cloud, Internet of Things, network, and critical infrastructure environments. So this is the diagram. You can see we have incorporated with quantum computing like qubits, superposition, quantum algorithms like source algorithms, Grover's algorithms, with the inclusion of artificial intelligence, machine learning, and deep learning. See here, we are using quantum resistant encryption, intelligent threat detection. We are solving by incorporating, see here algorithms, my dear friends. We are leveraging with artificial intelligence techniques, deep learning techniques, machine learning techniques, and quantum computing algorithms. We are solving quantum resistant encryption application, intelligent threat detection application, quantum enhanced anomaly prediction, secure key distribution, etc. That's why this this concept is emerging and so interested right now. It can solve problems like quantum resistant encryption, intelligent threat detection, and secure key distribution, etc. So these are the topics you might have seen last 5 days: qubits and superposition, The fundamental unit of a quantum information qubit is and its ability to exist in multiple states simultaneously. That is called superposition. The strong correlation between two or more qubits, regardless of distance, that is links happening between two states or more than two states with help of entanglement. Quantum gates and circuits, we are building block. These are the building blocks and computational models used like computational models like Grover's model, Shor's model used to manipulate qubits. And we are using quantum algorithms like specific computational methods designed for quantum computers, Shor's and Grover's. My dear friends, these two algorithms I have implemented and I'll give you the code you can utilize for your research. Quantum hardware technologies. I am going to share my PPT to your coordinator and you can use directly that code to for your application. So what is meant by quantum hardware technologies? See, we are using traditional systems computing, the backbone cloud computing. There in cloud computing backbones are data center and virtualization. I have explained already data center. Data center is a collection of high integrated computing servers at one place is called a data center. For every MNC having their own data center. High computing servers like supercomputers. Okay. So Indian supercomputer is a Param. Now it is replaced by some private organizations. Still they are working in it is located at IASC Bangalore. So the physical realization of qubits, example, we are using superconducting, trapped ions and photonic. This quantum computing came from the quantum mechanics. Whoever is strong in quantum mechanics, they can learn very easily this subject. So quantum error correction, that is QEC, and fault tolerance, I have explained. So in a data center, 100 servers are running, computing at a time, and it is giving service to the public all over the world. One server is not working properly, and remaining 99 servers are giving service. Instead of that one server is not working, still it can initiate and continuing the service, providing the computing power for the required people. Such kind of tolerance is called fault tolerance. Okay, so quantum information theory. So the study of information processing task using quantum mechanics. And what about quantum cryptography and post-quantum cryptography? So cryptography is a concept. We are converting plain text to ciphertext to plain text for encryption, for decryption. To solve cryptographic applications, we are using our quantum computing algorithms like Grover's algorithm, Shor's algorithm for searching, and cryptographic algorithms. It using quantum principles for secure communication and developing classical systems resistant to quantum attacks. We are using those algorithms. Then what about quantum machine learning? So machine learning is nothing but learning from the observational data with the help of supervised learning, unsupervised learning, and reinforcement learning. We are solving the complex applications with the help of operations like classification, clustering, association rule mining, outlier detection, recommender engine, whatnot. So many operations we are performing under machine learning. So quantum simulation and applications using quantum computers to model complex systems like chemistry and material science, especially to find the complex chemical reactions. How do we can find out contaminants, PFAS in a groundwater, soil, and the crop, weather forecasting, so many in the air. So many chemical reactions happening in the material science. We are finding nano computing applications. Okay, in microplastics also, how do we can identify, classify the microplastics? By using this quantum computing, we can solve and we will get solve optimization problems with help of this quantum computing algorithms. So no need an introduction to all this quantum computing. I think everybody knows. It is a new computing paradigm. It uses qubits instead of classical bits, and it is a basic unit of quantum information. It enables solve the complex application very faster, such as cryptography, optimization, large scale simulation, etc. And it is developed some research labs right now. They have their own tools in quantum computings like IBM, Google, Microsoft. They have released quantum computing models, and some experience lets users experiment with real qubits, how the Google's product is working, and some applications. Okay, so this is a qubit, this is superposition. See, with 0 or 1, the combination 0 or 1 with at a time exponential computing power we are generating. These are the fundamental concepts, and it represents both 0 and 1 simultaneously in superposition. That's why, so Bloch's sphere highlights how quantum states can be visualized, demonstrating the unique power of qubits in quantum computation. And these are need of quantum computers to solve drug discovery, especially material science applications, financial modeling applications, cryptography applications, artificial intelligence problems. So especially these are the applications we are using quantum computing requirement. It is need for quantum computer to solve complex applications. So 0 or 1, that is classical computing, whereas qubit from 0 to 1, n number of computations, n number of options it is generating. 0 to 1 means 0.01, 02, 0.0001, so many combinations parallelly it is generating. And we can solve exponential computing power. We can utilize and solve complex applications. See here, classical versus quantum. It uses binary system, it uses qubits, it uses transistors and logic gates, it uses superposition theorem, and it uses memory storage. Here it uses quantum tunneling, and the processing methods in classical computing, quantum entanglement we are using. So how quantum computing works. So everybody knows last 5 days, and we are using these 4 major concepts to solve computing applications. Hadamard gate, how I think all the 5 days you might have seen this explanation of all the 4 concepts, especially qubit, superposition, entanglement, and interference. So this is one of the architecture for solving a quantum computing workflow. Uh, See, we are using quantum computers. See, in the top layer, application layer, then it follows the classical processing in order to solve a digital processing, then analog processing, then quantum processing unit, and the last quantum computers. This is a layered architecture, and it explains how algorithms move through classical to digital and analog processing layers to interact with the quantum processing units and generate excellent results with our requirement. So, so computing units, so in quantum computing, it calculates with qubits, which can represent both 0 or 1 simultaneously. Computing capacity, can you see the capability increased exponentially with the number of qubits, and error rate and environment, whereas in quantum computing, it is very high. Some quantum systems need to be kept ultra cold. Then suitability, in classical computing, we are using suitable for routine processing, whereas in quantum computing, we are using suitable for complex processing. Okay, so these are the major differences. So this quantum computing, we are incorporating with so many fundamental concepts, applications and tools, eco-friendly system. It illustrates principles like so solve complexity, fundamental operations and assistance, applications of quantum computing, And you can see the number of companies having their own quantum computing models. IBM having Qiskit, and Microsoft having Q-Sharp, and Google having a Circ. This product came in July 2018. And Rigetti Computing, they have a Piquil, and ETH Zurich, Spanish, in Europe. Silk and Quantinium, they have TKET in the year 2021. See, these are the big giants in the market. They have started in quantum computing in the year 2017 itself to solve the complex applications, especially data security, boosting artificial intelligence, urban traffic flow modeling, improved climate prediction accuracy, designing cutting edge medicine, drug discovery. In order to solve, we are using these models. Which model is giving, until unless you do the practical work, you can identify which model gives very best results. So these are the uh, uh, major applications like drug design and molecular simulation. Now traditional systems and classical computing uses very slow such kind of complex application. If you use quantum computing, it gives faster drug discovery, simulation of molecular interactions at the quantum level. Medical diagnostics, we are using quantum computing. It enhanced pattern recognition, early disease detection we can find very easily. And Monte Carlo simulation in the radiotherapy we are using. And AI in healthcare enhanced by quantum computing. We are using quantum computing like improved image analysis, data analysis, maybe X-ray image analysis, maybe CT scan images analysis like COVID-19. I have a 1 lakh patients X-rays, so my system unable to process. That's why I'm using quantum computing so that I can improve the image data analysis, predictive healthcare analytics, etc. And then genomics and personalized medicine, we are using this quantum computing for efficient data analysis of genetic interactions, optimizing personalized treatments, etc. Then this is a quantum classical computing integration. This is architecture, how we are getting the data with the help of quantum hardware like qubit connectors, interconnect circuits for control operations, and quantum computing RAM, quantum processing unit, quantum registers, quantum logic gates, quantum memory. See, so many quantum and classical computer interface we are using. Quantum programming environment, I'm using Python. See, there are some already inbuilt programming languages developed by IBM, Microsoft, Google, quantum assembly language, quantum algorithms, quantum circuits, and we are storing in the databases that is called cloud data center. And in the network level, we are solving a business application that is high level language. So the left side part is quantum computing layers and the right side is a classical computing layers. These are the advantages of quantum computing. See, last 5 days you might have seen so many industry persons and professors might have explained so many benefits such as a speed, first point, and AI integration with inclusion of leveraging of machine and deep learning techniques, unbreakable encryption applications like cryptography, personalized medicine, and climate change modeling applications. So these are the so many 10, 12 advantages like explore multiple possibilities because once you are using quantum computing, we are generating exponential operations with parallel number of possibilities we are generating. So tackling intractable problems, unbreakable encryption, enhanced material design and discovery, and optimization and logistics, accelerating climate change modeling, and unprecedented computational speed advantages, revolutionizing AI and machine learning, harness entanglement, personalized medicines, breaking current encryption methods, breaking the language barrier. So many things we are getting advantages. So these are the applications. You can see finance industry, artificial intelligence, logistics, healthcare, supply chain management, material science, etc. I'm moving very fast because some practical demonstration is there. So these are the applications: cybersecurity, drug design, financial modeling, weather forecasting, etc.
Sir,
These are
sorry to interrupt you. Sir, sorry to interrupt you.
yes.
So valedictory session is also there today, and if you conclude means we'll invite our principal sir and dean academics sir also to the session, and we'll start
Yeah,
with the valedictory session, sir.
yeah, sure. What is the time now? Sorry, Dada. I don't know. What is the
It's
time? Oh, 7.
7:41,
Oh,
sir.
sorry. Oh, yeah, yeah. Please, please.
Yeah, sir.
So, yeah,
So
sorry for
I
that.
I call sir, and the meantime, I request if you can conclude. Otherwise, the participants I make the
Sir,
platform
these are
open.
practical demonstrations are there, sir. You. I thought that the time is there.
Uh,
Sorry.
I'll just open for the participants, and if they are ready, mics are allowed
Yeah,
and
yeah,
cameras
please, sir.
allowed for them. Yeah, they can interact now.
Yeah, yeah, please, sir. Sir, please invite principal. So we should not trouble principal, sir, and other
Yeah,
management
yeah, it is there.
people.
Yeah, yeah, yeah.
Yeah,
We'll
sorry.
continue with that. And
Please
you
involve
give
them.
your details because I need to understand that there are
Yeah,
things to be noted, like Python programming you have executed and understood that there is a prediction and as well as the expected depth of year you are telling, but exactly those classical Python programming might give only year. But if you still apply this quantum programming
quantum.
and quantum algorithms, will give
Yes,
exact date, minute, second as well, and then you can even die now. By knowing
exactly.
the date, you can die now.
It is very
Okay, excuse
interesting
me, excuse me.
concept right now,
Yeah, yeah,
emerging
yeah. Please,
quantum
please.
computing.
The platform is open for question and answers
Yeah, yeah,
now.
please, my dear participants, and
So please be interactive with the speaker. Meantime,
yeah,
I'll
yeah, please
invite
invite your
the
principal, sir.
delegates.
Please,
Yeah,
please.
yeah.
Already
Please
10
get them,
minutes
and
late.
we'll start with the valid precision. Thank you.
Yes, yes, sir. My dear friends, how many are there? Please interact with me. Any doubts, please? Any doubts
Srinivasulu,
related?
sir.
Sir, sir.
Sir. Myself, Dr. B. Ajay Kumar, sir.
B. Ajay
I'm
Kumar, sir. From where,
yes,
sir? Which college?
sir. Yes, sir. I'm working as a polytechnic lecturer, sir.
Yeah, sure, sir. Sure, sure.
Sir,
Please tell
it's
me.
really enlightening. It's really enlightening session, sir. We feel that before your presentation and before this session,
Ah,
probably AI and computing and deep learning all are some extended long topics where the people are not able to understand easily. But
okay.
after your session, it's really very good, sir. So
Yeah,
there is only
thank you.
one request, sir. I will approach you and I will even subscribe your channel and probably if you share your personal details once again along with your mobile
Yeah,
number
yeah.
and
My
email.
personal details are
Yeah,
there
yeah.
here. Please note down,
Yes, sir.
sir.
Yes, sir. And one more thing is, yes, sir. I have noted, sir. One more
Yeah,
thing, sir. If it is possible, can you recommend at least a small projects for diploma standard people?
yeah, sure.
Particularly, we are using cyber security along with quantum computing tools to make women
Sir,
security.
Ajay, sir, I'll give you immediate response for this one.
Sure, sir.
You can see this program I'm sharing.
Sir.
December 5th, excellent program is there. December
Okay,
5th.
sir. Okay, sir.
I think I have already shared with one of my colleague Chalapati sir. This is the
Sir.
program.
Sir.
Here also I'm demonstrating cyber security applications with practical.
Sir.
With the fundamentals, I'm going to explain for your polytechnic students.
Sir.
December 5th is the program. I'll give a concession for this through university. We are conducting this program.
Okay,
I'll
sir.
share this link.
Sir.
Immediately, you note down my number. This
Sure,
is my
sir.
number. You can
Yes, sir.
contact. This is
Yes, sir.
not the platform right now. Please,
Yes,
we are
sir.
already late.
Okay, sir. I understand, sir. I understand, sir.
Yeah, yeah. Please, please
Thank you,
note
sir.
down my
Thank you.
number, and you
Sure,
can.
sir. Sure, sir. Already, sir. Already have noted, sir. Thank
We
you, sir.
will allow you. You are all polytechnic students. December 5th. Okay.
Sure, sir. Sure, sir. Thank you, sir.
Yeah. Okay, sir. Any other queries? You can give feedback. Whether you liked my lecture or not, please no hesitation. You can give your own negative feedback, positive feedback, whatever. This
Good
is
evening, sir.
good evening, sir. Please, what is your name and which
This is
college you are?
this is Dr. Mujib from Lord's Institute of Engineering and Technology. My
Oh, nice
question
to
is,
meet
sir, as you mentioned about that we can predict the future, we can predict the date of the death. So, is
Yes.
there any way using the quantum models can we predict the back dates?
Yes, sir. Yes. Still R&D is
Hmm.
ongoing. Very good question. And we haven't applied so far quantum algorithm. Now we are getting very interested to solve such kind of complex applications. And I'm going to implement soon such kind of algorithms. And I'll be contact with me. With the collaboration, we will do some papers on this concept.
Okay, sir. Thank you so much, sir. Thank you for the reply.
Yeah, sure.
Good
Any
evening,
other
sir.
feedback?
Good
Yeah,
evening,
ma'am.
sir. Sir, myself, Dr. Fanindra from Srinivasulu University.
Yeah. Please tell me,
Can you
ma'am.
hear me?
Yes.
Only one question I would like to ask.
Sure.
Nowadays, laptop cost around 50,000 rupees. So, what would be the cost of quantum computer, sir?
Uh, See, right now, all the big giants like IBM, Google, they have started. And see, recently, Nara Chandrababu Naidu and Lokesh are invited. They are starting quantum computing hub at Vijayawada. It's very,
Yes, sir.
I think it takes time to get for normal people like us for purchasing a quantum computer. And
Yes, sir.
let's see, right now, I don't have any idea for that. What is the cost of each company having their own prices? Uh, Soon we can expect that answer for your question. Yes,
Thank you,
sir.
sir. Thank you very much.
Yes. Any other queries related to our topic or any your generalized questions also, please?
Sir, hello. Hello.
Hello. Please
Sir, I'm
say your name and
Dr.
college, sir.
Hello. I'm Dr.
Sir.
Shravan Kumar from Vidya Jyoti Institute of Technology, sir.
Yeah, sir. Nice to meet you, sir.
Sir,
Please tell me, sir.
yeah, very wonderful session, sir. This time, paucity of the time, we are unable to interact you much, sir. Please
Yes,
share today's PPT, sir.
Yeah, sure, sir.
In that
100%.
your address and details are there. We will be in touch with you through mail and other resources, sir.
Yes, sir. 100%, sir.
Thank you very
sir.
much, sir. Yes, sir.
Sure.
Thank you.
Any other participants, any feedback from your side, please?
Hello, sir. Good evening, sir.
Good evening, sir.
Yeah, my name is Dr. Koteshwar Rao, sir. I am from IS Engineering College.
Yes, Hyderabad, sir.
Yes, sir. Hyderabad, sir.
Sir, please.
Really very good session, sir. Really
Thank you.
appreciated for your efforts, sir.
Yes, thank you.
In future, I would like to collaborate through mail, and if anything is there,
Please
please
note down my
give
number.
some guidance.
Yeah.
Sir, please can you give, sir?
Yeah. It is there
Yeah.
in my screen.
Yes. Yes, sir. It is there, sir. Yes, sir. Definitely, I'll touch with by mail, and if any guidance, please, we'll be
Yeah,
collaborate, sir.
sure. Thank you, sir.
Thank you very
Any
much.
other
Okay.
participants having any doubt, please? Please unmute yourself and you can ask any query related to quantum computing. Feel free, my dear
And
friends.
also, I'm interested, sir.
Yeah.
I'm also interested in quantum computing, and
Yes.
so that I'd like to collaborate, and in future, sir,
Yeah,
please, we
100%, sir.
can.
100%. I
Thank
have
you, sir.
incorporated so many concepts today so that
Yes, sir.
the research is not in limited. We can do many things.
Sure, sir.
Sir,
Yeah,
I have seen there are around 2,800 or 900 slides, sir, in your presentation.
Yes, sir.
Sir, I'm sorry to say that neither principal sir nor our dean academic sir is answering the call, as in the morning itself they have informed that we might be busy or we may have some meeting in online with IICT people.
Yes, sir.
And also principal sir shared one of the video links of those to share the participants as well. And I think they are in that program.
Yes.
In that perspective, I requested our Dean Faculty of Arts to join for this validatory session. So Sir will join soon, and once join, we'll start the validatory session, sir.
Yeah, sure, sir.
Dean Faculty
You
of
can start
Arts.
your valedictory function, sir. Dada Miya, sir.
Yeah, we are waiting, sir. Let's you are the chief guest, however, and let
Yeah, sure. No
Vivek
problem.
Kulkarni sir from our college as Dean Faculty of Arts will join and will complete.
Yes, sir.
Good evening, sir. I have a small doubt. Myself, Dr. Naresh Kumar Reddy.
Yes, sir.
Sir,
Sure, sir.
with the help of this quantum computing in future, shall we predict exact shares, especially the share market, which share
Yes,
will
yes.
be going
Yes, yes,
within
yes.
15 days,
Yes, sir.
20 days, and 100
Yes,
days?
Yeah, very good question.
If it is if we got accurate answer, then everybody will invest on that. Then again, it will be difficult or
No. Your
sir.
share market, every second it changes. Okay.
Okay.
So definitely it will not give you 100% accuracy again.
Okay.
So there is a chance again.
Mm.
So we can solve some extent.
Sir, then bullion market, it is a difficult task, na, sir?
No, not like that. See, there are some advantages, there are some drawbacks again. Okay. Yeah.
Yeah,
Maybe
Prof.
we can predict. Maybe we can predict. Yeah.
So sorry to interrupt the participants and the speaker. Dean Faculty of Arts of Vardhaman College of Engineering has joined the program. Now
Yes,
I
sir.
request participants to give a valuable feedback on PDP for the last 6 days, including today. One or two
Yeah, please.
participants can give their feedback. Then valedictory session will start. Please go ahead.
Yes.
Give your name and college. Then you give your feedback, please.
Hello, sir. May I talk?
Yeah,
It's me,
please.
Yeah,
Frimpong.
sure.
Yeah, good evening, sir. My name is Frimpong. I'm talking from China, Yanzi University.
Yeah.
I'm very happy to join this class because quantum distance is my first time of hearing all these things. I'm doing crop technology in PhD.
Oh,
Crop technology. So I want to know, I mean, use quantum computer for my course?
yes. 100% you can use quantum computing. What is your name? Mr. Frimpong. Yeah.
Frimpong, yeah, Frimpong. Yeah, dog,
Yeah,
yeah.
Frimpong. Yeah. It's a wonderful question. You can use quantum computing with the inclusion of AI, machine, and deep learning techniques. You can make a hybrid model for your research, for crop prediction, for crop any kind of improvement if you want to do based on current challenges. Any environmental engineering problems also you can use this quantum computing. 100%. Your question is right. Your question is valid. And regarding to your question, you can use 100% quantum computing algorithms for searching, classification, for clustering, whatnot. If you want to do detection, prediction, and recommendation, many things we can do with help of quantum computing. Very good question. Keep it up. Next
Thank you.
participant, please give a
Participants,
So do
please.
you have a full
related.
course of this one? Do you have a full course of quantum computing course?
Yes. CRC Care at Australia and at the University of Newcastle, we have introduced, and we are taking a training on this full course training. Okay. Next participants, give feedback about the entire professional development program, PDP.
The speaker is always
Sir,
available.
myself, Dr. M.V. Subbareddy.
Yes,
Sir.
Sir, from
Nice
Saira
to-
Eswari Institute of Technology, Puduttur, sir.
Yeah, please, sir.
The sessions are from Monday to Saturday are going very well and giving the information, full information about quantum computing.
Yes.
Even a layman can also understood, sir, the concept.
Yes.
Thank you very much, sir.
so thank you.
Each and
Thank you for your feedback.
What about today's
sir.
session? You like that or not?
Srinivas, sir, I like it, sir.
Okay. It's okay.
Last one
Like it very
participant,
much,
please.
sir.
Yeah, thank you.
one participant last. Anyone? Last
Madam,
opportunity.
any professor, madam, associate professor, madam, please speak about this workshop. Any negatives, positives, please share so that we can improve.
If no one is there, then I request our Dean, Faculty Affairs of Vardhaman College of Engineering, Professor Vivek Kulkarni sir, to address the gathering on a 6-day online professional development program. Yes, sir. Please, sir. Over to you, sir.
Thank you, Dada Miya sir. Good evening, all the participants, and very good evening, our guest of honor, chief guest for this evening, Shri Srinivasulu sir. Of course, I could hear all the feedback, and almost all of them are positive. I'm really happy that some learning has happened over the last 6 days, and I'm confident that definitely there are a few takeaways from these these sessions. Hope this PDP was really fruitful, and hope you will remember uh, some of the topics, and then you will take back to your institutes, organizations, and of course, will spread this word. I'm again thankful to the chief guest for this evening, Shri Srinivasulu sir, for taking out time and being with us and sharing his thought. I also congratulate the organizers of this PDP for putting in effort and then making this PDP a grand success. Uh, Thank you all the participants. Thank you, and all the speakers. Heartfelt thanks from Vardhaman College of Engineering. Thank you, Dada Meir sir.
Sir,
Please
thank
take it from here.
Please, sir. Thank you very much. Now I request Dr. P. Shailaja madam to express a vote of thanks.
Thank you, sir, for giving this opportunity. Sir, is my voice is audible?
Yes, madam, you're audible.
Okay, thank you, sir. A very good evening to everyone. On behalf of Physics Department, Vardhaman College of Engineering, I, Dr. P. Shailaja, Assistant Professor, take this opportunity to express my heartfelt gratitude as we conclude the one-week professional development program on exploring quantum computing, fundamentals, algorithms, and emerging applications. First and foremost, I extend my sincere thanks to our distinguished resource persons who enriched us throughout the week with their deep insights and expertise on quantum computing basics, algorithms, and emerging applications. My heartfelt appreciation goes to today's speaker, Dr. Asadi Srinivasulu sir, as well for delivering another enlightening and engaging sessions on quantum computing for cybersecurity, emerging quantum applications like drug delivery, AI and quantum computing, generative AI, and many more. Sir has given complete picturization of quantum computing and its various advantages and challenges. Your contribution has added immense value to this program, sir. Thank you, sir, Dr. Asad Srinivasulu, sir, for spending your valuable time with us.
Thank you.
Thank you, sir. I would like to express our deep gratitude to our beloved management, principal, and guest of honor for this program, Professor Javier Ravindra sir, and special invited Dean Academics and HOD ECE Department, Dr. S. Rajendra sir, HOD Physics Department, Dr. Dadamiya PMD Sheikh sir, for their constant support, encouragement, and for providing this wonderful learning opportunity. I also thank IEEE advisory members, Dr. Sangeeta ma'am, Assistant Professor ECE Department, Dr. M. Siddhartha sir, Associate Professor Chemistry Department, and Dean Student Affairs, Dr. Muhammad Asif sir, and Dean Faculty Affairs, Professor Kulkarni sir, as well for their help in conducting this program in a smooth manner. A special thanks to the organizing committee members for their dedicated efforts in planning, coordinating, and ensuring the smooth conduct of this PD. I also extend my sincere appreciation to all the participants for your active involvement, enthusiasm, and cooperation throughout the program. Your presence and engagement made this event very meaningful. Finally, thank you everyone for making this professional development program a grand success. I wish all the best in your future academic and professional endeavors. Thank you everyone.
Thank you, madam. Thank you for your vote of thanks. And about this certificate distribution, I tell all the participants, be patient. We will give the certificates based on the statistics what we have made on the quizzes as well as the feedback forms you have submitted. We will share surely. Almost all will get the certificates. So we have finalized the certificate also, and we'll issue the certificates. So you need not worry. Thank you very much, sir. A special thanks to Dr. Asadi Srinivasulu sir for joining us today as a chief guest as well as the speaker. So thank you very much.
Thank you, sir.
So with this, we close today's session and also the 6 days PDP program. Thank you all.
Thank you.
Thank you, sir.
Thank you.
Thank you.
Thank you, sir. Srinivasulu,
And
sir.
I have
Thank you
shared the
very much.
feedback form also for today's session as
Thank
well
you,
as
sir.
the overall session. You can give the
Yeah,
feedback.
I'm going to
Thank you.
share my PowerPoint presentation to
Yeah, sir. Yeah, I have to
coordinators.
share to the participants. Yeah,
Yes,
yeah,
yes.
that is
And
there.
people, one or two people are there, at least 100. Can I expect a subscription of my channel, YouTube channel? Please,
Yeah,
my
yeah,
dear
that is up to
friends.
them, sir. You need not ask.
Sure,
That
sir.
is
Sure,
we
sir.
show, and that is up to them.
I
They
don't
will give.
know.
They,
If they like,
sir,
they will do.
yeah, yeah, sir. They
Thank you,
like,
sir.
they'll do. Yeah, thank you, sir.
Sure, sir.
Thank you, ma'am.
Good evening, sir.